Our fellow resident, Ron Kay, who's lived here for 7 years, had a career at IBM, but he retired a long time ago. He's not a spring chicken. His last years at IBM were spent at the Silicon Valley Research Lab, and after that, after he retired, he went to UC Berkeley and founded the International Computer Science Institute, which had artificial intelligence as one of its major activities. And that was, Ron, when did you go there? 1990?
88.
88. So
Wow.
he's been involved with artificial intelligence from the beginning.
Most of us knew it existed.
Anyway, Ron is going to talk to us tonight about artificial intelligence, mainly the stuff that exists today, not all the blue sky stuff that we hear about and read all the articles about. So please welcome Ron Kay.
Thank you, Steve. I want to be clear that Steve deserves a great deal of credit, not only for doing this, helping me getting set up and so forth, but he's also organized a couple of TED Talks at the end of the week. And these TED Talks are also on the subject of artificial intelligence. And I hope that what I have to say will inspire you to want to know more and come and see these. But I think we all owe great thanks to Steve for doing all of the work. For the purpose of this talk, I offer this definition for artificial intelligence. The part of computer science which aims to help machines, by machines I mean computers and robots, perform tasks which require human intelligence. I don't think this is a controversial definition. There are many other definitions that are. And in the course of this talk, I will talk some about computer science so that you can get an understanding of where artificial intelligence fits into computer science. The thing that I fear the most is dealing with this machine. Neither artificial nor intelligent. Okay.
I can hear fine. Me too, but we've got good ears.
What I'm going to be talking about are some significant current applications of AI to give you an idea of the role these applications play in the world today, rather than their scientific importance. I hope that what you will take away from this talk is some understanding of what AI is all about and some ability to judge for yourself the hair-raising stories that you read about in the paper. So that's my objective. Starting with computer games, today that is $100 billion per year industry, 3 times the size of the movie industry. Imagine there are 900 million simultaneous users in the Asia-Pacific region and 200 million in North America. at any given point in time, they're playing computer games. These computer games are largely based upon the technology which is based on artificial intelligence. I will talk about speech recognition, which has been and continues to be a challenging problem for AI. It is not perfect and is not likely ever to be perfect, but will probably improve some more. I will talk about automated call centers, one of the early success stories to give you some understanding of what has been the basis of success of an artificial intelligence application. Next, I will talk some about machine translation, which has become generally useful only in the past few years, and you will learn why this works so well. So the significance of machine translation as an application is not that it makes so much money, because nowadays it is included in the software that comes with your phone, but rather it is an example of something in the large range of applications of artificial intelligence that has been extraordinarily successful from a technical point of view and from a user point of view. I will allude to stock trading, and the reason that is a significant application of AI today, 80 to 90% of the stocks traded on the New York Stock Exchange are machine traded and run by artificial intelligence programs. The volume of trades today on the stock market in New York is about 2 to 3 billion trades per day. Obviously, you're not going to do this by a bunch of people sitting there punching keyboards. I also want to make you aware of some people who have had a major impact on AI in our world. Computer science, if you want to go and get a master's or a PhD degree in computer science in Berkeley today, you need to take a certain number of units from each of the 3 listed groups of courses. The 3 groups, theory, AI, and human-computer interface, are not rigorous divisions of scientific note, but simply groupings which could vary with time, with the school, or the emphasis a particular school puts on their particular offering. Under the heading of AI, you see computer vision. That's the subfield which aims to understand and emulate functions of the human eye and the brain functions that serve the human eye, that enables us to see, and in this case, makes this capability available to the AI-run gadgets we have. Robotics is one of the most important subfields of AI, huge field, enormous economic significance, which has and will continue to have a major societal impact. The fact that this has been so very successful, in part, is due to the fact that both the military and the space program have invested huge amounts of money and a huge amount of talent in advancing robotics. But it now dominates the manufacturing business all over the world. Natural language processing, that is a collective name for speech recognition, translation, speech understanding, You notice the distinction between speech recognition and speech understanding. You really have to pay attention to that, because I can recognize a word to the point that I can repeat it or write it down or enter it into a computer with a keyboard. So recognition means it is available to a computer to process. It doesn't mean that you understand the word. For example, I can recognize a German word, Gesundheit, without understanding what it means. It happens to mean health. But there is a great distinction between recognition and understanding. So we're talking here about recognition, which is the easier of the two problems. Statistical learning theory has become a major and dominant field that has pushed AI, artificial intelligence, ahead. And it is a subject that I'm not sufficiently familiar with that I could summarize a meaningful definition in a few minutes. But as we go along, I will give you some examples of AI application that make use of statistical learning, so you'll get some feeling for what that's all about. So the final subject on this here is not really related to course content, but rather that is what every graduate student has to do, has to do an independent research program, and that's just, and I lifted that thing straight out of the Cal catalog. Under the theory, I have highlighted one phrase, data structures, a concept that you will take home tonight, I promise you. So before we go into all this scientific stuff, I want to present you with something that's of immediate benefit. An effective way to rise in the esteem of grandchildren, your own or your friends, is to empower them, to make them look good in the eyes of their teachers and peers. To teach them the idea behind an elegant data structure is a sure way of achieving this. In early 1700, a young boy by the name of Gauss, Carl Friedrich, he was age 6, he was assigned the problem of adding all the numbers from 1 to 100 by a teacher expecting to keep the class busy for a while. Those of you who are teachers, you know what that's all about. Before the teacher could return to her desk, Gauss raised his hand to tell her that he had the answer. So she asked to see his notebook, and he told her that he had done it in his head. How did he do that? Okay, here you see the numbers from 1 to 49 in one column, column A. The numbers from 51 to 99 in another column. And the third column is the sum of A and B, the one left in the middle. Lo and behold, each one of these pairs of numbers add up to 100. There are 49 of them, so that's 4,900. And what we have left over here is 50 and 100, so the answer is 50-50, 5,050. You all followed Carl Gauss along on that?
Yeah.
That is a data structure, and if you Google the word data, or the expression data structure on Google, what you get is a particular way of organizing data so that it can be used effectively. Now, when you read this definition, it means absolutely nothing. But once you've seen that, you understand exactly, one, what a data structure is and what it means to organize data so that it can be used efficiently. And that's essentially what people who work in AI, what they do. They try to figure out ways of organizing data structures in a way that you can do something useful with them. In this case, add them up. So if that is not enough, I have another item here, which is good for a dinner conversation. And I don't mean to freak you out, but this is called multi-dimensional or n-dimensional vectors. Now, don't be freaked out by these words, like doctors use Latin names for a cold. AI people like also use these complicated words. It's actually a very straightforward idea. You all are comfortable with the idea of 2 dimensions or 3 dimensions. If you want to look at an architectural rendering, you have to have 3 dimensions, X, Y, and Z. And if you are an air traffic controller and you want to identify the position of an airplane, you need 6 dimensions, east, west, north, south, and whether the plane is coming or going.
Okay.
Question?
No, just how high it is, too.
This air traffic controller is going to be in trouble, right? I was not prepared for, I was prepared for questions, but not for critical questions. Sorry about that. But the most interesting is the one that comes closer to n, which is a large number. Here I have 13 arbitrary, it could be 100 or 1,000. Voter profiling. You want to have a data structure that allows you to profile voters, not thousands, but millions of voters. So you want name, you want address, age, sex, and so forth. So the word dimension is really a shorthand or a geek's word for a feature or property. And as we go on, many of the applications that we'll be talking about, they made use of such n-dimensional vectors, and the process of these vectors are what makes these AI applications function. So much for the science. I promise I will not put up any equations. So we'll go to the first application, computer games. Computer games are largely based today on AI technology. What makes them significant is that this is today a $90 billion a year industry. 3 times as big as the movie industry. There are in the Asia-Pacific region 900 million people using, playing computer games every day. North America, 200 million. The significant thing about computer games is there are no barriers, either educational or linguistic. That is, you don't have to be barely literate in order to play a computer game, so it's accessible to anybody. Anybody can play a computer game. And it happens that computer games are designed to become addictive. So people play computer games, they don't stop. This chart, 2012 to 2021, was done in 2016, so that 2 years of verified numbers, and it represents the business volume associated with computer games worldwide. So we're talking about $180 million per year. And you notice the real growth is the top section, the dark blue, which is due to mobile devices. So one very important issue about applications of AI is it's not just brilliant people inventing things, but there has to be a basis for a market. And the basis for the market is the growing market for mobile devices that has made it possible to have this kind of game or gadget to play games in the hands of millions of people. Very important consideration. You can't think of artificial intelligence applications as something by itself or of itself. It is a concept that is fed by many other aspects of what goes on in our world and in our economy. Here I have, for those of you that don't play computer games, shown you what these games are about. And the interesting thing to observe is that these are the 10 most popular games, and you notice that the difference between game 4 and 5 is about $100 million per year. So when I say significant, you may not be impressed by 900 million people playing these games, but when you look at these numbers, you can see this is a significant business. The interesting thing about these games is that, for example, Fortnite, the one on top, costs nothing to play. So you may say, well, how do they make money? Well, they have a great many features which you pay for, like multiple players playing either with each other or against each other. There are even features where you can go and watch professional game players. I mean, people who do this for a living. People who pay money in order to see others play these games. Now, this may seem remarkable to you, but talk to your grandchildren and you will certainly get a long lesson. I have a grandson who changed my mind about computer games. He says they represent the absolute forefront of popular culture today. So if you want to know what young people are thinking about, watch some computer games. So this is significant both in its scope and the coverage that it has. The games vary in sophistication and technical capability, from simple animated games that little toddlers play. After all, you've got to prime them for this challenge in their lives. And technically demanding super realistic war games based on leading edge AI innovations. We're going to go on to speech recognition. And what's the significance of speech recognition? I can put that into a nutshell. Humankind is not meant to communicate one character at a time. That is, this business of hitting a keyboard, that's not the way human beings were meant to be. And if you reach my ripe old age, you will find that a 2x2 keyboard is not a tool, but a source of frustration. And it is not meant to be. Also, there's a growing need for hands-free communication. People spend more time in their cars, various other activities, multi-processing human beings that are being raised in our world, that you can't have a device that requires you to operate keyboard. So that's the significance in a few words. In 1939, my first visit to New York, one of the attractions of the 1939 World's Fair was a demonstration where you could speak into a microphone any of the numbers 0 to 9, and a number would light up in the display. And that was the first demonstration of speech recognition. One word, one number at a time. And at the time, I was very much impressed by that. This was in 1939. It took 50 years for the first large vocabulary, speaker-independent, continuous speech recognition system to be demonstrated at CMU, Carnegie Mellon University in Pittsburgh. 50 years, I mean, that's a long time. And it's not that these people didn't try or that they were not smart people. So then it took another 30 years before Apple and Google and others came up with speech recognition like you are now using on your phone or on your gadget that you have on your bedside, Siri and all these things, that understand speech and in fact will answer you in very understandable English. So you ask the question, what's so hard? Well, why did it take all that time? What's the problem? People are still working on this, by the way. There's a concept, word error rate. That means how many words were not recognized or recognized and had the wrong word. The best today is about 3% word error rate. In other words, 3 out of 100 words cannot recognize or is recognized and faulty. So what's the problem? Well, there are a number of problems, and the significant thing about these problems is there are no straightforward answers to how do you solve those problems. And in fact, you can say with some certainty, we'll never have 100%. Because when you converse with someone else, very often a word misses you, but that doesn't stop you. Because as a human being, you have context, was said before, what was said afterwards, you know the person. In fact, some of it you wish you didn't hear. So we have a capability that we have as yet not been able to project into machines. It's a very difficult problem to deal with. But specifically, what's so hard is the problem of segmentation. That is when words are concatenated, that is, say you slur the word together. Very, very difficult problem to tell when one word ends and another one starts. That stopped this speech recognition from being practical for a long, long time. It's one of the very, very difficult problems. Then there's a question of noise. There is continuous noise, like if you drive a car, you have road noise, or if you are speaking in our cafeteria, or listening in our cafeteria, there's a hell of a lot of noise, and you very often don't hear what the person that is talking to you is saying. So if you think that there's a way of solving that by filtering out the other noise. What you're filtering out is speech. That's what you want to hear, so it's a really difficult problem. So the problem of dealing with speech is very, very, very tough problem. Will never be solved 100%. If somebody slams a door, you are not going to be able to understand, nor will the machine. And there is absolutely no way that you can correct that. If you had a brain that could interpolate or guess what we said, you may have some success. And if you were not just recognizing words, but you were understanding what those words are, you could use your common sense, which is also a very difficult thing to implement in the machine. As you have noticed, it's difficult to implement human beings also. So noise is a real problem. Then there is a question of speaker independence. We're not talking about one person. You can easily train a system to recognize one person, but you want to recognize everybody. What is more, you want to recognize people that speak different languages. So now we're talking about multi-language recognition. And we're talking about dialects, and we're talking about people that mumble. We're talking about people who are under the weather and are not comprehensible. The system does not analyze who they're talking to. It either understands or it doesn't. And when it doesn't, then you say it isn't working, and your word error rate goes up. At the more future-oriented level, one of the requirements of a modern-day speech recognition system is it amenable to machine learning? That is this a system that you continually have to add to or correct or improve, or is it capable of learning itself? Like a child learns a language or learns to speak by continually babbling and being continually corrected until finally it is tired of being corrected and says it correctly. And that's what you would like to have. And there are today the most advanced aspects of AI is speech recognition is where in fact that is possible. So this is what is so hard. And the problem of speech recognition, we're down to about 3% error rate, which is very good for many, many applications. Certainly very good if you are talking to your mother-in-law, who you wish would hang up anyway. But it's not so good if you're talking to your banker and you're making a deposit. You want that to be 100%. So word error rate, that is a real problem, and I don't think we will ever have perfect speech recognition, just like we never will have a situation where you understand everything your friend or companion has to say to you. So that's the reason things are so hard. Now let me talk about some of the successes, some of the things that really work, and in fact work very, very well. They work so well that you are not aware of talking to a machine rather than a person. And one of the earliest such applications has been call centers. When you're calling the billing department of your phone company to complain about an item on your bill, first thing you're asked is the number on the top right-hand corner of the bill that you're looking at. And as soon as you have said that, you are asked, excuse me, you're greeted by name, your name,
Yeah.
and asked for the date of the call in question and the amount. So while you are looking at your bill, looking for the call that you want to complain about, that you either didn't make or is longer than you thought it was, while you're doing this, the system, what I call the system, that's the AI program in the gadget that you're talking to. That's the system. The system programs you are interacting with, looks up your account history, and there it tells them what kind of a customer you are. You're paying your bill on time, you're a good customer, or you're an occasional customer, you're a constant complainer, you use the system all the time. And above all, how big is the amount compared to the total bill? And if that number is very small, they will, in a very courteous way, say, "You are such a good customer, we absolutely will credit you for this call." That's cheaper than negotiating and it fits in a rack. So this program handles millions of calls per year, and it's not, such programs, call centers, are not confined to bill pay, but every interaction you have with a internet vendor, I mean somebody that you bought something on the internet, you interact through a call center. So this is a huge industry, and the telephone company, the US AT&T, that first developed this call center program, have recovered their 50-year investment in this technology within the matter of a few years. It's an extremely effective way of using speech recognition. Now, what is the basis for the success? Why is it so successful? One, limited vocabulary. What you have on that bill and the number of words that are on there are the same on their system as are on your bill. So it's a very small vocabulary that they deal with. A very important feature is that the system is capable of immediately verifying the accuracy of your complaint. If you identify the date you made the call, but in going over to look at the amount, you've dropped down a line and you give them the wrong amount because you've dropped down a line inadvertently, they come back and say, "Oh, I'm sorry, but we did not find a call on that particular day which had the number, the charge that you are making reference to." So you're looking and saying, "Oh, I'm sorry, I just came down the line." So it has the ability to immediately correct your inadvertent mistake. The most important condition for success is the feasibility of human backup. That call center has a bunch of people sitting there answering the calls of people who don't have computers. They're obviously also available in the case that you have made a request that they don't want to honor. So at that point in time, the computer system says to you, "I'm sorry, I can't deal with that here. I don't have the data to support a decision. I'm going to refer you to a specialist."
Right.
And that's the way they can handle the feasibility of human backup is key to successful call center system. Another very important feature of such a system being successful is that it is scalable. You can make such a system that services 100, 1,000, or 1,000,000 people, and it's the same, roughly the same effort or investment on their part to put that system in place. And it's not limited to billing, it is limited, it can be applied to anything that you do online. I quickly want to mention personal assistants, things like Alexa and Siri. They're as yet not significant, but they're on the way to becoming significant. They address a much less demanding role, very limited vocabulary, and with time, these gadgets will do more and more, and they will become significant. They're projected to be $23 billion by 2025. So that is about to be significant. I want to introduce you to a fellow by the name of Kai-Fu Lee, and I think that in the material, the TED Talks that Steve is going to present on Friday, you will meet the guy in person. I think he's talking on one of these TED Talks. Notice, born in Taiwan, his father was a historian and legislature and a nationalist in Taiwan, emigrated to the US when he was a kid, went to school, high school in Oak Ridge, Tennessee, he's an American citizen. He knew what he wanted to do. He wanted to study computer science. He went to Columbia University, which at that point in time was the outstanding school, most renowned school in the US in computer science. He was accepted for a PhD program at CMU Carnegie Mellon, which at that time was the leading institution in speech recognition. He got his PhD and he made a contribution that was sufficient to get him a faculty job upon graduation. I can assure you to get a faculty job at CMU, at the computer science department, you've got to be good. 2 years in the faculty, then he became principal research scientist at Apple. He started their AI department. And after 6 years, he went to Silicon Graphics. That was, at that time, a scientific computer company. And he, within that period of time, which was 2 years, became the president of their software division. Wow. This guy was good, and he was not only good as an academic, but he was good in doing things in industry. He joined Microsoft, who gave him the job of starting a research lab in China. That research lab today is one of the greatest in the world. That he has to his credit. In 2005, he was recruited away from Microsoft by Google. And they paid him a $10 million bonus to come to work for them. Wow. In 2005, he quit that job and he became the founder and, in 2009, founder and CEO of venture capital fund in China, Innovation Ventures, which currently has $2 billion under management. 2 billion. 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 2 billi This explains to you why in the year 2013, Time magazine named him as one of the 100 most influential people in the world. This man has put China on the fast track in AI, and I think that it is not an accident for that being one of the most influential people in the world. I think on Friday you will get to meet this guy in person. I mean, on the screen. He's, I think, presenting some of the things that Steve is presenting. It's based upon that. If you think about that kind of a resume, you say, hey, I would like to have this guy work for me. I mean, this man, I'm only sorry that he's working for the other side. Very smart guy. Significant I've thrown this in here in order to allay your fears that my information may be dated. This is from April of this year. What it says is, today as the head of AI at Google, one of the largest organizations in this field, Jeff Dean's focus centers on speech recognition, language understanding, computer vision, robotics, and healthcare. By the way, the word healthcare is a euphemism for the joining of bioscience and AI, artificial intelligence. This is a very controversial subject. I don't want to go into the controversy part of it, but that's what healthcare is all about at Google. Now to an application, machine translation. That is relatively new in terms of being practical and generally useful, and is not so much that it has made so much money or can be measured by its financial impact, but technically it is a very good illustration of a successful application of artificial intelligence. For many, many years, the mathematicians proposed statistics as the solution to this problem, and vis-a-vis the linguists who were advocating a grammar and syntax-based, rule-based system. All I can say is statistic 1. And I want to now explain to you how this system works. And I think that I have prepared an example which should serve to make it reasonably clear to you as to what this is all about. What you see here is the page that comes up when you click on to Google Translate on your computer. And the first 3 lines starts up with Google Translate and then text documents. That's all you got in a way of instruction to this program. And what you do is you start typing in the word or the sentence or the novel that you want to translate. And I have typed in here a German sentence. For those of you that know German, haben Sie alle in Käfigen gesehen? This came out of recent American newspapers where people are worrying about, did you see them all in cages, is the translation of that bottom line on the right-hand side. Now, what I have done here, rather than just type in the sentence, which is the bottom line on the left, and get the translation, which by the way is perfect, on the right, what I have done is, for every word I put in, I repeated the previous word so that you can see how this system works. So on the right-hand side, you see to have is the English translation for haben, and so on as you go on down. Now when you look at the right-hand side, you notice that 2 words become 3 words, the word order changes, and in fact the words themselves change. What's going on? Here's what's going on. In each case, the system is looking for, get this straight, the string of words you see on each line on the right-hand side is the statistically most frequently encountered string of English words, which corresponds to the string of German words on the left. That is it. There is nothing else that this system knows how to do but look for the most probable string of words corresponding to the string of words that you have in there. That is all. There is no intelligence other than statistical occurrence. For example, on the 3rd line, you see on the left, haben Sie. Obviously, that's not a typo, but that means the word Sie has 2 meanings. And those of you who know German, of course, can readily see this. So here you have a system which is relatively stupid. I mean, all it does is look for the statistically most frequently encountered string of words. Does it make sense?
That's
So it's a fairly simple idea.
yeah.
But to implement this, to design a set of data structures with n-dimensional vectors, which are now not just words, but strings of words, that is quite an achievement, and this came out of a project in Germany in the year 2005. So this is not all that old. It is today the most frequently used system, most successful, and it works fantastically well. Now, why does it work so well? It works so well because it has, by virtue of context, some of what our brain does. It looks not at the word in isolation, like the first word, haben, is the word have. But when you find it in isolation, in German it's one word, and in English it is to have. You don't ever see the word have by itself.
Right.
So, I hope you got the idea. Now, the virtue of this system is that the more you use it, the better it gets. And it gets better not only because it addresses those sentences that are most frequently encountered, which are the ones that are most useful, but it gets better by virtue of having just more data.
Yeah.
And what is challenging in the design of such a system is, first of all, you have to get a huge amount of well-translated text
Yeah.
for your training material to train the system, and you have to maintain that because word usage changes and new words come into play. So I hope you've gotten an idea how such a system works, and you can also relate that what was said about data structures. Clearly, to organize a dictionary that does that, you have to do some clever manipulation to come up with something that works and works consistently. So we talked about machine translation, more and better data. And we have more and better data by virtue of the fact that there are millions of people using that, and every time they use it, they add one piece of data to the statistics. Better data means people learn as they add new phrases to the system, what is useful and what isn't. Better performance by virtue of increased computing power, which has nothing to do with artificial intelligence. But if we didn't have cheaper and better computers like our cell phones, this would not work. Increased memory means we have room for larger vocabulary. Increased speed means we can do a whole paragraph or a whole page that we transfer into our system. I think you understand that. Another person I want you to meet that has made a mark in AI, Robert Mercer, native of San Jose, California, PhD from University of New Mexico. No, excuse me. He got his BS in New Mexico, and Urbana, Illinois, got his PhD in computer science. He worked for 20 years at IBM Research. I knew of him, I did not know him personally. After 20 years at IBM, where he covered himself with glory, he was a highly respected man. He went to work for Renaissance Technology. That's Jim Simon's fund. What is the looking for the term?
Venture capital.
No, not venture capital. The people who do hedge fund. So he joins Renaissance Technology, the most successful computer-driven hedge fund in the world, started by Jim Simons. He was co-CEO there. And then in 1917, he left Renaissance and he got into politics. He used the same technology, AI, that he used first to work on speech recognition at IBM, and then made $430 million worth at Renaissance Technology. And then he went on to bankroll the campaign of our President Donald Trump. And he also was a major source of funds for right-wing political causes, and part owner of Cambridge Analytica, the company that helped put Brexit over the... So, talking about people who have had influence upon our world and the role that AI has played. And that's what I wanted to convey to you, that one could and will talk about AI and its promise and its problems ad infinitum. That's an infinitely long subject, one that's very challenging, and on Friday we'll hear some of that. But I wanted to essentially give you an understanding of what is the facts as they are currently are. From that, all of us can extrapolate what is going to work and what isn't. And I've also tried to give you a feeling for what is necessary for these things to succeed. It's not just a good idea or brilliant science, but the conditions for adapting these has to be there. So, what we've talked about is significant applications of AI. What do they have in common? High value, dollar value outcome potential. This is not something that a few kids do in their garage and make millions. This requires an enormous investment in time and money. Very high entry cost. And the companies that today are the leading companies have an enormous advantage over anybody that's trying to compete. Because just to gather the data which is necessary to make these systems work, that's 10 years of effort. You don't start with 1 million, you have to start with 100, work on it. Global markets. If you want to compete in this, you have to compete with China and with Europe. So you have to be prepared to fund a business for investors, to fund a business that has global reach, which makes it more expensive yet. You have to, above all, have massive data, and you have to have access to it. And every time you fill out a questionnaire on your computer, and you ask, almost every interaction you have, you ask to fill out a questionnaire, big or small. That's where the data comes from. Okay? So you are providing this data free of charge to the person that's asking for it. It's the basis for that business. Very controversial subject, but that's the way you get massive amounts of data. You obviously need highly skilled people. This is a very complex business. Most of the people that do well at this have a degree in higher math or have the capability and have been trained and are fluent in higher math. This is not Carl Gauss counting to 100. This is many orders of magnitude more complex. And one of the today requirements for a successful and significant application of AI is the potential benefit from machine learning. That is, the process itself helps you get better and be able to reach further afield. I want to give credit to my son Tony, who is responsible for these fabulous slides. He's a professional. And I'm open to questions.
Is that guy the last result?
Yes. That's very frightening. It's more frightening than anything else. It's so far beyond our training.
Yeah, but to understand what it's all about.
Yep.
I mean, what the people are doing are straightforward things.
That's right.
The tricks that are played mathematically are astounding feats. They're very, very competent people. The guy that runs this Renaissance Technology, Tim Simons, was a very famous mathematician before he ever got into hedge fund management. And when you listen to what this guy did, as a little kid, he added numbers from whatever and multiplied by 2. That was one of his hobbies. So these are people who have unusual talents and very abstract thinking, much like musical composers that are sort of totally outside of the range of what the ordinary person can do.
Yeah.
Memorize 100 scores.
Yeah.
And so this is a business that has very few mediocre people in it. If you're mediocre, you don't last in that business. So this is a very expensive shop to run. And you know, if you have to pay somebody $10 million to get them to come to work for you, not very many people can afford it.
Yeah.
Yes.
I just wanted to say that last summer I was in Moscow and St. Petersburg in Russia for 3 weeks. And with my phone and Google Translate, I could have verbal conversations with people who didn't speak English. And I, of course, didn't speak Russian just by passing my phone back and forth. It was fabulous.
Google Translate, if you have a computer, just go and get the program and start
It's wonderful.
using it. You're amazed at what that program does. It is fantastic. It really is.
You know, you can, when I show a TED Talk, for example, I know you all like subtitles. You can't always understand the words. And the closed captions, it's really comical sometimes. Probably it's a 3% error rate, but there are some really wonderful mistakes that the translation program makes. And it's amazing because that translation is instantaneous.
Yeah.
Another question, Anne?
Well, I don't know whether it's related or not, but we used to talk about something like heuristic learning. Is that what you would say that the speech recognition is doing? Or the translation is doing?
And I'm afraid
I don't know what that means really.
it's going to take a little more time than we have here. I think it is, and this, in preparing this, it was not what to say, what not to say. Within a given amount of time, these are complicated ideas, so you have to sort of boil it down. And off the top of my head, I can't answer you in a reasonable, in a satisfying way.
I just would like to compliment you on the comprehensive reduction of the material in the space of 1 hour.
Yeah.
Because Frontline on November the 5th had a 2-hour presentation on artificial intelligence, and it was really awesome. I recorded it and watched it last night, and you touched on many of the things that they elaborated in that program. But the complexities are enormous, and the future is
Frightening.
just staggering for artificial intelligence. I think it would be possible to go to pbs.org and pull that up on your computer, and I really recommend that people do that. One tiny example, which they start off with, is the game, the Asian game of Go, the ancient Chinese game of Go. It was developed in China 4,000 years ago. It's a very complex game that the emperor back then used to teach his son how to think. And it's a very challenging game to play. I've never played it, but they found in Korea the world champion for the game of Go, and he was challenged by Google. And Google had taken many games and their outcomes and various elaborations, put them into a computer, and the computer beat this guy with creative thinking based on all the data that they had put into the machine. So it was thinking better than a human could. It was really impressive.
Well, humans are fallible.
Yeah, I do have a question. It seems to me that these big companies like Google, Amazon, et cetera, are competing in the same areas. Do you have any idea of whether one is going to be more successful than the other? You know, for example, General Motors was at the top and now is not.
First of all, General Motors' interest in AI has been concentrated on robotics, and Google's has not. So there are many aspects of AI that we haven't even mentioned, let alone talked about. I think that General Motors probably still has a very good robotics department, and they have to concentrate on that aspect that's most relevant to their business. So this is not a judgment of what do they do scientifically, but what makes sense for them to do.
I more in mind, like Amazon and Google, they're competing in the same area.
I think that if you get into the future of AI, you will recognize that there are societal problems that stand in the way of that just marching ahead. There are problems like fooling around with an election that we're going to have to do something about. I mean, we're not going to just fold up and say, forget about democracy, we're going to have computers do that for us, and whoever pays the most gets their way. So there are some problems to be resolved as to what society, how society is going to cope with that. And that is a problem which I think is much more difficult to contemplate than just talking about something that we can understand. The concern is justified, but the one thing that you learn when you're in that kind of business is you have to take it one step at a time. First of all, you have to survive in your business. General Motors has to survive in the automobile business, and they were behind on electric cars. They've more or less lost the luxury market, so that's their first problem to solve. So they will continue to work on AI as it relates to their business, but whether they will ever go beyond that is questionable. And to them, it's not all that significant. I think that Mr. Bezos, at some point in time, will have to accept the fact that he too, like all of us, steps into their pants one leg at a time, and that he's not going to run the world. And if he doesn't understand it, the rest of the world will, and they will. He can't grow forever, and at some point in time. So what is he going to give up? He's going to give up that part of his business that is the least profitable. And that may well be AI. So he's not married to AI. On the other hand, companies like Google and Facebook, their entire business is dependent upon it. Mr. Putin's government is based upon surveillance of people. The Chinese government is based upon surveillance of people and control of people. That's their first
Objective.
their first priority. So there are things that influence AI that have nothing to do with AI per se, but how they fit in with our society. That's a whole other discussion. And as I say, I've limited myself to something that I hope that you could understand and get a better feel for what is it that AI is all about. And as I say, I would love to. And after Friday, when you've seen Steve's TED Talks, I am entirely amenable to have you send me an email and we can arrange something to get together to talk more broadly in a less structured way and explore some of these ideas. It's not that I am not for doing this, it's just that within an hour, I did the best I could.
Well done. Thank you, Norm. And I hope to see you on Friday. We have three TED Talks.
4:30? What time?
3:30.
3:30.
3:30. I'll be putting up posters right now in place of Ron's posters.